Hi everyone, welcome to another episode of the Data Standard Audio Experience. Today I'm here with Sean Robinson, a lead data scientist at Graphable, and today we're speaking more about data models. So welcome to the show, Sean. It's so great to have you.
Thank you. I'm happy to be here.
Yeah, and could you just go ahead and tell us more about your background and go ahead and introduce yourself?
Yeah, absolutely. So my name is Sean Robinson, and I'm a lead data scientist here at Graphable. So I really got my start as a data scientist at a large financial institution where I was introduced to kind of two big concepts, one of which being financial crimes and the other being graphs and graph databases. And it was pretty quick that I realized like these two things play together quite well. And so I started to kind of understand, how to apply graphs to these fraud type questions, and then ultimately surface those results. And I kind of fell in love with graphs as a result. So I now teach network science and graph theory at the University of North Carolina at Charlotte in our School of Data Science. And I recently joined Graphable as a lead data scientist. So now I'm surrounded by graphy people all the time, and it's a good way to be.
Yeah, and that's great that you're teaching but also doing industry work. I think it's great experience on both ends. And I know a lot of your work is just working with graphs, but can you please define what exactly a graph is to our audience?
Yeah, absolutely. So at the end of the day, a graph is just a data structure that we've had around for over 100 years in both graph theory, which is more of a side of mathematics, but as well as a data structure in computer science. So for anybody who's ever taken a data structures course in college, you probably covered graphs. So they're nothing new, but have had a real surge in the last several years, specifically with the rise of graph databases. So really, when we're talking about a graph, we're just talking about a different way of structuring our data. So most people, when we think of data, we think of these long sheets of rows and columns. So this could be a traditional RDBMS database, or something like an Excel spreadsheet where we have a list of records which are related to maybe some other information in this vertical horizontal format. Graphs kind of throw that out the window and say, okay, we're going to think about this in a totally different way. So rather than thinking about maybe a given person and then listing their address as a separate column, we treat these as individual nodes, which are connected together by relationships, or edges, as they're sometimes called. So in that scenario, rather than kind of having this rows and columns format, I would have nodes that represent the people in my data, which are connected to their various addresses. And this offers a lot of intuitive understanding of our data that rows and columns can sometimes be hard to follow, because at the end of the day, graphs structure our data much like we structure our thoughts in the human brain, in that we think of things as these ideas which are connected together by others. So that's at the end of the day all a graph is, but the way that it surfaces that data allows us to understand the interconnectivity of that underlying data source in a much more intuitive way.
Yeah, and thanks for defining that to our audience. And how are graph databases different from other databases that you might be working with?
Yeah, so graph databases are really built from the ground up on a lot of concepts I just talked about. But the main thing that they offer is kind of this interconnectivity in your data. So there are several things as far as like query times and stuff that can be much more performant, especially when we're talking about these interconnected type questions. But at the end of the day, it's saying that, rather than storing things in these rows and columns like I might in a traditional RDBMS database, which I would then have to connect together by joins, all my data, all my records, which are stored in my database, I store as nodes at the lowest level. And this offers me a lot of advantages in specifically, accessing other records rather than having to access a record, find some information about it, then do another scan for a related record with that information. I can simply follow the path, which is much cheaper when it comes to things like computation time. So a lot of the time they're accomplishing the exact same thing that a traditional RDBMS database would do, but they're doing it in a totally different way, and in ways that can be much more performant.
Yeah, super interesting stuff. And how do you work with clients to help them really integrate with graphs?
Yeah, so at Graphable, while we love graphs and we love to build applications with graph at the center, we by no means believe that graphs are a complete replacement for people's data solutions. So the number one thing that we're interested in at Graphable is first understanding our client and understanding, why do your employees go to work every day? What drives your revenue? And what ultimately drives your data sources and where that data is coming from? So once we kind of have an intuitive understanding of that data landscape, the next question is, where do graphs fit in for you? Right? So maybe graphs are just a complementary data source, right? That you just have, kind of added onto the side for you to help answer your most difficult kind of interconnected questions. We see this a lot for reporting, where executives are asking more and more complex, more and more interconnected questions of their data. And so graphs offer a really great source for those dashboards or reports or whatever it is that you're ultimately surfacing up to leadership, because they can help answer those questions in a much more sustainable way. It can also be maybe more at the center as a single source of truth. This is a common use case we see, where maybe I have many system of records, which maybe refer to the same entity or person or process. And I want to consolidate all of that so that when I'm producing reports or for my application or whatever it is, I'm only referencing a single source of truth. And not only does that offer me this consolidation of my data, it also offers me the benefit of being able to analyze the lineage of that data. So not only can I tell you that this is a single consolidated record about perhaps one of our customers, I can also audit that and tell you where that record came from. And so I can say, yeah, this is a consolidated record, but then also trace it back to where did it originate in our data sources for that explainability.
Yeah, and super interesting stuff that you're working on. And with all of the work that you do, especially in industry, I'm sure there's some challenges that you have maybe encountered with the work that you're doing with your team. So what are some challenges that you can talk about there?
Yeah, so one of the things is learning graphs can be a little daunting for some people, because they really do kind of take the way we think about data traditionally. And a lot of the techniques which we would apply to data that we're taught coming up through technology are done on relational structures or flat structures. Graphs kind of have their own toolbox. And so there can be a little bit of a learning curve with graphs. I see this a lot with my students, but once people get over that hump and they kind of get it and they start thinking in terms of a graph, then the questions that they start asking become much, much more intelligent, become much, much more detailed, and you can start to kind of surface these hidden patterns that lie dormant in your data that you wouldn't find otherwise. So there's a little bit of a learning curve with graphs, but it's not terrible to get over.
Yeah, no, that's great. And I know you also mentioned that you work in industry versus academia. You're doing both right now. And so what is kind of the differences that you've seen between working with the two? Since I know you're doing graphs for both areas a lot, but are there any other key differences that you've really seen?
Yeah, I think the key difference is obviously pacing and motivation, right? So when we're working in kind of an academia setting where maybe our goal is research, the forces which are on you are very different. And so there can be, your timelines can end up being maybe longer or, more sporadic with the way the semester lands. Well, with industry, you're there to ultimately produce a profit and to empower an organization to, solve questions, reduce costs, generate revenue, whatever that is. So the motivations can be different, but at the end of the day, what we're trying to do is answer questions using graphs. So how we approach them ends up being the same, but the forces which are kind of acting as these forcing functions can be slightly different and create different parameters by which you have to operate under.
Yeah, definitely. And can you also tell us more about your experience with PPP fraud, otherwise known as Payment Protection Program?
Yeah. So for anybody who's not familiar, when we were in the thick of COVID-19, the Congress released several sets of funds around keeping people at work, essentially. So if I'm a struggling business, I can apply for one of these loans, and they're intended to help keep people on payroll, right? To keep our economy going and to help sustain through this storm of COVID-19. However, due to the speed at which this had to be implemented, it unfortunately left it rather vulnerable to fraud. So while I obviously can't really get into the details too much for confidentiality reasons, as much as I would love to, at the end of the day, we can think about something like PPP fraud in really simple terms when we think about it in a graph, because at the end of the day, there are three things at play here. We have companies who are applying for loans, which are connected to some lender. And just through those three different entity types and the way they're interconnected together, whether that be a person applying for a loan or a lender granting a loan, we can very quickly build this graph structure of the data and start looking for patterns. So if there are specific patterns which we know are indicative of illegal activity or just straight up illegal in general, graphs really help us surface those results to the top and quickly identify those patterns and then potentially surface those results to law enforcement should that be necessary.
Yeah, super interesting stuff that you're working on. And I wanted to say thank you so much, Sean, for joining us today and being a part of our podcast. We at the Data Standard, we're trying to build a community where everyone can just network and collaborate with each other in the data space. So what is something that the community can help you do?
Yeah, the number one thing I would say is, reach out, stay in touch. I love to talk about graphs, and graph data science. So if, people are curious, I would say stay curious about graphs. That's probably the best thing you can do. There's a whole host of resources out there on the web about how to, utilize different techniques. So stay curious about graphs is what I would say.
Yeah, great. And where can everyone find you online to connect with you?
Yeah, so you can find me on LinkedIn and GitHub at Sean K. Robinson, and you can find me on Twitter at Sean_K_Robinson. And you can find Graphable on YouTube, LinkedIn, and Twitter, all at Graphable or at graphable.ai.
Perfect. And to our audience, for more information on the Data Standard, you can find us at www.datastandard.io, as well as on our LinkedIn and YouTube channel. Thanks so much, Sean, for joining us today. It's such a pleasure to have you on the show and just hear more about your experiences in both academia and industry work. So thanks so much.
Yeah, absolutely. I'm happy to be here.